Paris, the detection of gravitational waves, remnants of galactic cataclysms that occurred billions of years ago, opened a window on the origins of the universe. Here's why their discovery earned 3 U.S. astrophysicists a Nobel Physics Prize on Tuesday. Gravitational waves are ripples in the fabric of space-time caused by massive astrophysical events, as when two black holes crash into each other and merge. Albert Einstein first theorized their existence over 100 years ago, and their detection in 2015 finally confirmed a key element of his world-changing general theory of relativity, which describes the force of gravity. The discovery of the waves was also a big deal because they allow astronomers, largely limited to what they can see, to witness things telescopes cannot detect. With their mere existence, gravitational waves provide evidence of historical galactic events such as star implosions. Normally, when we try to understand what is going on, we only see the bits of the universe that happen to emit light, Chris Lintott, a professor of astrophysics at Oxford University, told AFP. We have this horrible bias when we look at the universe in that we get distracted by shiny things. But with Einstein's waves, scientists have found a new way to pry into the universe's oldest secrets. They have created an ultra-sensitive device which uses a laser beam and mirrors to detect the ripples. We have a window back in time. It won't get us all the way back to the Big Bang, but it may get us very close to it, said John Butterworth, a professor of physics at University College London. Light does get us a long way back in history, but for very big objects, the waves, might get us further back. One of the challenges in proving Einstein right was designing equipment sensitive enough to detect gravitational waves. Humans have certainly come into contact with the ripples before, but without knowing it. We are being stretched and squashed by gravitational waves, but to be honest, the scale is just ridiculously tiny, Carolyn Crawford, an astronomer at Cambridge University, told AFP. We would never feel it. Gravitational waves are minuscule and near undetectable because they interact very weakly with matter and travel through the universe at the speed of light unimpeded. For many years in the 30 or more year history of the LIGO project, it was not anything anyone in the mainstream cared about, said Lintott, using the acronym for the Laser Interferometer Gravitational Wave Observatory, which spotted the waves. This was almost like Don Quixote. I think a large number of people were skeptical that you'd ever build an experiment sensitive enough, he said, referring to the famous novel about pursuing lofty ideals. Today, there are 3 wave detectors in operation, opening all sorts of new possibilities. The key thing with that is you start being able to see where the waves, are coming from, Butterworth said. The more detectors you have, you can start triangulating where the wave came from. Then, you can point your telescopes in that direction, hoping to catch a glimpse of something unusual. The grander story is that we want to understand how the universe has evolved over the last 13.8 billion years, and the formation of black holes is a crucial part of that, Lintott said. One can use gravitational waves to investigate the very early period of the universe, the first fractions of a second, but for that we'll need to build on from where we are now, he said.